Okay, today we're going to be working with word problems that have non-integer exponents. They could be fractional or they could be decimal exponents. So this is the example we're going to work through today. According to Kepler's law, the period of a planet, or the time it takes for the planet to make one revolution around the sun, varies with, well, it should say varies directly, but it varies directly with the 3/2 power of the planet's average distance from the sun. The Earth is, on average, 150 million kilometers from the sun and has a period of 1 year. And this is what we're going to have to find from this equation. A, find the equation that relates period in terms of distance. B, predict the periods for Mercury, that has an average distance of 58 million kilometers, and Pluto, that has an average distance of 5,913 million kilometers. And C, if Mars has a period of 1.87 years, what is the average distance from the sun? So part C, we're going to be working backwards in the equation. So as I said, for these, most of these are going to be directly proportional. So we're going to use the equation y equals kx with some exponent. We've got to figure out what the exponent is going to be. In this case, we're going to use y equals kx to the power of 3/2. Or if you like decimals, you can write it as y equals kx to the power of 1.5. Okay, so here we have the basic general equation, and we're going to use variables that represent what we're looking at. So we're using the variable p for period, and we're going to use d for the average distance. Okay, so we have our general equation here, p equals k d to the 3/2, and as I said before, you could use p equals k d to the power of 1.5 if you want. We're going to plug in the values for Earth that we know to find k. So we know that the period for Earth is 1 year. So we're going to plug in 1 for the period, and then we know that the average distance, or d, is 150 million kilometers. So we're going to plug in that 150 for your distance. We raise the distance to the power of 3/2. When you're doing that in your calculator, you just type in parentheses 150 and then your power button, parentheses 3/2, and then push enter. You type it into your calculator and you get 150 to the power of 3/2 is 1837.1. To isolate k, we divide both sides by 1837.1, and we get k has a value of 0.0005443. So then our general equation here becomes period equals 0.0005433 d to the power of 3/2, or again, if you like decimals, you can write it as d to the power of 1.5. Now we're going to use the equation to find some other values. The first one we were asked to find was that for Mercury, which had an average distance of 58 million. So we're just going to plug in that 58 for D right here. Again, when you're typing it into your calculator, type in 0.0005443 parentheses 58 to the power of, to the power of parentheses 3 divided by 2 end parentheses. Or, as I said before, you can type in 0.0005443 58 in parentheses to the power of 1.5. And you should get an answer of 0.24 years. Do the same thing for Pluto, except plug in 5914 for D, and you should get an answer of 247.5 years. Okay, so here's the last part. Now we're going to have to work backwards in the equation. When we're given a value for P, can we plug it in and can we find D? So this was Mars had a period of 1.87 years. Can we find the average distance? So you get 1.87 equals 0.000543 d to the power of 3 over 2. First you got to isolate d. So you've got to divide both sides of this equation by 0.000543. Oh, I made a mistake there. I copied it wrong. It should be 5443. 5443. So you get 3433.08 equals d to the power of 3 over 2. Now we need to get d to the power of 1. So to do that, to get d with an exponent of 1, what we do is we raise both sides to the reciprocal exponent. So I'm going to raise this side to the power of 2 over 3, and I'm going to raise this side to the power of 2 over 3. You can see that these exponents here, 3 over 2 times 2 over 3, is going to give me d to the power of 1. So, and this side is going to be 3433.08 to the power of 2 over 3. So again, you type that into your calculator. You know, you type in 3433.08 and then your exponent button, parentheses, 2 over 3, and it should give you an answer of 227.6 is your distance. So on average, Mars is 227 million kilometers away from the sun. Now, if you're doing it with your exponent being 1.5 instead of 3 over 2, it still works the same way. Okay? You still do the same thing. You plug in your 1.87 for your, you plug in your 1.87 for your d. So you do 1.87 equals 0.000543 d to the power of 1.5. And again, you divide both sides by 0.000543. Divide by 0.000543. And you still get 3,433.08 is equal to d to the power of 1.5. And you still do the same concept that I'm going to raise both sides to the reciprocal exponent because I still need to get d to the power of 1. So here my reciprocal exponent is going to be 1 over 1.5. And I do the same thing to this side, 1 over 1.5. So when I'm typing this into my calculator, I type in parentheses 3433.08 to the power of parentheses 1 divided by 1.5, and that is going to equal d to the power of 1, because this 1.5 times 1 over 1.5 is going to give me d to the power of 1. So when I type it into my calculator, I still get that 227.6 is your average distance from the sun.